My name is Omri Gazitt. Sorry for starting a little bit late. We had the prior session running a little bit late as well. So we are going to try to end this one a little, more or less on time, take about an hour and 15 minutes, but that will give you 15 minutes to go to your next session. As I said, I'm Omri. I'm going to take you on a guided tour around the Windows Communication Foundation. Kind of rolls off that tongue, that name. Formerly known as Indigo. I'm going to say Indigo a lot in this particular session, so forgive me for that. Just kind of regex replace Indigo with Windows Communication Foundation will all be fine. Here's the obligatory "You Are Here" slide. Indigo, or sorry, the Windows Communication Foundation, is part of WinFX. As you can see, I spent 5 years working on XML, and I can't stand it when there's XML that's not well formed in any slide. So I added little underscores, underbars in that Windows Vista developer reference so that my validator inside my brain could actually parse that particular slide. But we are talking about the Windows Communication Foundation, the service model, and related APIs here. This is probably a good slide to use to talk about how we are delivering the Windows Communication Foundation to you. It's obviously going to ship in Windows Vista as a core part of the developer API of that product. It's going to be in the box, so to speak. And we're going to ship that the same set of APIs in a component called the WinFX Runtime Components that's going to be available for Windows XP and Windows Server 2003 at the same time that Windows Vista ships. So we actually spent quite a bit of time at PDC 03 talking about the whys of Indigo, back then it was called Indigo, of the Windows Communication Foundation. So I'm not going to spend a whole lot of time on philosophy, but give you a little bit of flavor for what we think WCF is all about. It's really about being the unified programming model for rapidly building service-oriented applications on our platform. It's really based on 3 different pillars. The first one is unification. We basically have a whole bunch of technology stacks today for people to go build distributed applications on our platform. We have the stack that's based on COM, with all the COM roots, COM, COM+, MTS, and enterprise services as the managed API manifestation of that set of technologies. We also have MSMQ as the message passing infrastructure, middleware that we have in Windows today. We have .NET Remoting, which is kind of the near programming model. This is the programming model that lets remote invocation look like a local invocation. And finally, we have the ASP.NET Web Services programming model, along with WYSI, the Web Service Enhancements, which were basically our first foray into building a service-oriented API for our platform. We basically took this opportunity with WCF to unify all of these programming models together and to create a single programming model that's appropriate for many different scenarios, appropriate for building near applications, appropriate for building far applications, appropriate for building applications that talk across devices and across different scenarios. The second pillar is the service orientation pillar. Now, when you do this kind of unification, you don't really do it very often. You don't do it with every release. This is not something that we took very lightly, but we felt like around 2000, when we first started the WCF project, that the fact that service orientation was fast becoming the new metaphor for integrating applications together made this a very good opportunity to go embark on this unification process of all these APIs, all these object models. And service orientation is basically kind of the successor to component orientation, if you will, for being an application architecture for basically combining and having different applications talk to each other. Previously, we had COM. COM was actually quite a success in its time, still a success to this day. Is exactly how people can actually go take MS-HTML, take the IE core, and go host it in their applications. Or how Excel and Word can actually go host each other's data, embed and link it inside those applications. And so COM ushered a whole revolution, so to speak, in how people could go take their components and expose them to the world for being able to integrate with new, exciting applications. When we looked in around 98 or 99 at scaling all this stuff out to the internet with DCOM, we realized that there are some inherent assumptions that we made with COM that just made it hard to scale that out. So for example, running on the same machine or running in a single trust domain. And we realized that the new fabric for integrating applications was going to have to be based on XML-based protocols, on text protocols, and we're going to have to go create a new technology stack. And service orientation basically codifies all the best practices for building these distributed applications that can aggregate content from each other and connect to each other. The final tenet or pillar for the Windows communication is integration. The whole motivation for service orientation to begin with is to be able to integrate with a much larger variety of applications, platforms, trust domains, organizations. The barriers for integration that have been there that Jim and Bill talked about in their keynotes are fast falling. And users are demanding, developers are demanding today an unprecedented level of integration between all these applications and all their assets. And so integration is a core tenet with the WCF. We want to make sure that we have a first-class interop experience with other platforms. The other, the other side of that coin, of the integration coin, is of course we want to integrate WCF services and WCF clients with all the existing infrastructure and developer programming models that we have shipped over the last 10 years. So integration is, again, a very key concept in Indigo, WCF. Programming WCF 101. So the rest of this presentation is going to be focused on just taking you through kind of a brief tour of what all of the main concepts in Indigo look like, and then delving a little bit deeper into each of these concepts. So WCF has, just like many other distributed technologies or distributed programming models, has very simple concepts. You have a client, you have a service. They communicate by sending messages back and forth. And indeed, with WCF, the core abstraction is message passing. And we build a whole lot of richness on top of that in terms of programming models that make the message passing look like, for example, a request-reply correlated set of message exchanges. Or we can actually build RPC-like semantics on top of that in our dispatcher. But the important thing to remember is, at the heart, Indigo is merely a message passing system. At the heart, a client passes a message to a service, and the service can talk back to the client using message passing as well. Endpoints are the details of communication for a service. A service exposes endpoints. A client picks an endpoint that a service exposes and goes and talks to that service over that endpoint. This is actually very similar to the whole Berkeley sockets model. I mean, there's nothing new ever invented in this earth, so to speak. And we validated the work that the BSD design team did on Berkeley sockets back in the the early 80s. So a service can host a number of endpoints, and the client picks an endpoint to talk to. Now, an endpoint consists of three things: an address, a binding, and a contract. We call these the ABCs of endpoints. And we designed those names, ABC, just so I could say it's as easy as ABC up here at the PDC on stage. The address is where you actually expose that service. The binding is the communication details, the how of actually talking to that service. And the contract is what you're actually exposing. Now, in order to instantiate these endpoints, in order to have something that's actually listening out there, something that actually goes off and talks to the socket layer, opens up the sockets, binds them, gets into the accept loop and the receive loop, you need something called a service host on the service. That's the thing that basically goes through, looks at all of the endpoints that you have in your application, and builds all the runtime machinery to make all those endpoints be able to listen to messages, to listen to connections and messages. The client channel is the analogous concept on the client side. The client channel basically takes that endpoint description and conjures up all of the machinery on the client necessary to go talk to that particular endpoint. So that's pretty much all the concepts that you need to know in order to actually go write WCF 101 or Hello World with WCF. Now, actually, in the interest of time, I was going to go and switch over to the demo machine, but I'm going to just go take you through slides very quickly on what Hello World looks like. And then in the other section, I'm going to go back into code and show you a demo application, how it's written. So very quickly, when I start building a service, I have a contract definition that I have to go create, and that's little more than just a CLR interface that's decorated with a couple of choice attributes. One is called service contract that says, I want to take this interface and I want to expose it to the world as a service. And the other one I have here is an operation contract. It says, I want to take this method and expose it as a remote method for people to be able to call. Next, I have to implement a class or construct a class that implements that iHello interface. And this is just the standard hello world. Takes a string, takes a name, returns a string, and returns me hello and my name. In order to host this service, I actually have to go create a new service host with that particular type of hello service, call host.open, and then so that I don't fall through the end of main and close everything up, I just call a console.readline there, just so as to block the console UI. And voila, there I have a self-hosted, what's called a self-hosted service. Now you can host services anywhere. You can host them in a console application. You can host them in an Avalon or a WPF application. You can host them in a WinForms app, in a Windows service. But we also have a code host called IIS and an activation system called the Windows Activation System that ships with Windows Vista. And those are kind of the common ways of hosting services with WCF, with a Windows Communication Foundation. So I can take that particular little line of script, which looks somewhat similar to how ASMX used to have that line of script of web service, and just put it in a .service file, host it up in an ISV root or any other web server that supports, obviously, the ASP.NET programming model. One of them is called Cassini. It comes out of the box in Visual Studio. And there I go. I now have a web-activated service that doesn't actually have to be running in the background. The HTTP request or the request over any other protocol will go activate that particular service. Next up is the service configuration. Now, I already showed you how to write the contract, and you may ask me, where's the address and the binding that you talked about in the endpoint? Well, I can actually go write that in imperative code. I can use those attributes, those snazzy attributes on classes in order to go specify those as well. But the most convenient method of specifying addresses and bindings is in config, because these are details that may actually change at deployment time, that I may want to actually go reconfigure when I move the app around. And so this is a very simple service. There's a service model section in config. There's a list of services in here, and I have one particular service. I pass it a type. This is the type of the class. And it has an endpoint with an address, a binding, and a contract. The binding is called basic HTTP binding. This is the most basic binding you can have, and I'll talk a little bit more about bindings and the standard bindings that we have in the system. And the contract is the iHello contract that I created. That's all there is on the service. On the client side, it's just as simple. In my main, I have a static method called createChannel on a channel factory class in that system.serviceModel namespace, and it's a typed method that gives me back an iHello proxy based on an endpoint that I specify in config. So hello endpoint is here in the client app.config file or web.config file, and I go get all the information from the configuration file, and then all I have to do is just call .hello on that proxy. That is, again, a typed proxy. It's of type iHello, so I can just call that method on it, pass it my name, get back a string, and write it out to the console. That's all there is to Indigo 101. Now let's go, oh, thank you. Let's go delve a little bit deeper into some of these concepts: contracts, bindings, the metadata system, and behaviors. The way I'm going to demonstrate this is through a little app I call Inster. And let's see. I'm actually a believer in, instead of writing random snippets of code that don't relate to each other, showing you, hey, this is how you do this binding, and this is how you do this binding, I actually tried to create an app that uses a number of different bindings in a semi-realistic scenario. Inster, yes, the marketing guys, I managed to slip through. They didn't make me rename it WCFster. But Inster is a little file sharing app that I wrote just in a couple of days. In a few days, I should say, not quite a couple. But it uses a whole bunch of different features in WCF, and it'll help us demonstrate some of the various aspects of it. So this is basically an app that I already have running to kind of save you from the cold boot times. You can go launch all these, and over here on this side, you can see it basically keeps track of all the folks, all my friends who are running the same app. It also shares lists of items that they have. So in this particular case, I have, in my copy of Inster, I'm sharing my, a couple of MP3s that I have. Don, my friend, is also sharing a couple of MP3s he has, and he has also an AVI file. One of the nice things about this particular application is I have contracts that are based on what's called the peer channel, where I can say, hello, everybody, and click on a chat button, and that should actually send it to everybody that's listening. And Omri says, hello back. Now that demonstrates some of the multicast contracts or multicast bindings that we have in the product. I can also, being Omri, I can actually go whisper to Don, hello there, Don. And this demonstrates the unicast kind of capabilities, and I'll go take you through all this code. And it takes a little bit of time, but eventually Don will get a little message that says, hello there, Don. We'll wait a little bit, or not. There it is. Omri whispered, hello there, Don. There's another capability here where if I am Omri and I want to see Don's content, I can go click on one of these guys. One of these is hosted by Don. Let's click on Sailing. Sailing is a little video that my wife took last week when we were in Hawaii. I dare not play any real music up here for fear of copyright violations. So I'm going to play something that's a piece of media that I actually own. And eventually it will come back. I don't know why this is being so slow today, but we'll give it a little bit of time to think about it. Ah, here we are. Sorry for being so loud. My content, thank you. The other interesting kind of functionality that I have here is another piece of the system that I want to demonstrate. Oh, I'm sorry, I forgot to indicate what was special about that particular content. This particular file is a stream and gets returned back as a stream to my application, and we'll see why that's significant in a second. Streams are actually dealt with in a special manner by WCF. You go to the local item list and try to actually add something, and here you'll see some of the dynamism of the system. I'm going to try to add a little song over here that I have in my item list. I'm going to call it music, and the artist is Death Cab for Cutie, one of the big emerging bands. I'm going to click populate, and this may take a while because this actually goes off. Oh, it didn't take a while at all. It goes off to the Amazon service, the Amazon public web service out there, and it goes and gets information about that particular artist that I have. So I do a search. I get back a whole bunch of data for Death Cab for Cutie, namely all the albums that they've ever put out. And this is the Plans album. And I think the song that I got in here is that first song, the Marching Bands of Manhattan song. Let's click OK. And now you can see I added it not only to my local list here. So Omri has Marching Bands of Manhattan over here. Don also got it too. And that's, again, a demonstration of the peer channel and how I can multicast all these things out. Finally, I have this little server running in the background that demonstrates, again, another aspect of Indigo, what's called a WS binding. And that server is there because when copies of Inster come to life, they can actually go advertise everything that they know about. Hey, here's my song list. But they themselves don't know of all the peers out there and all the items that are advertised by others. So they go to a server, and that server is also listening on the peer channel, getting back all the notifications, and registering all of them. And so when a peer comes up, it can just go get all the peers, get all the items that others are advertising, and that's how it kind of bootstraps. That's how it comes up to speed. So that's what the demo looks like, just in terms of the UI. Oops. I'm actually not going to look at code right now. We'll look at it a little bit later. Let's go back to the PowerPoint. Machine is for the stream I was talking about. So let us bring the code up. And let's see, what do I want to look at? Let's start by looking at what an Inster item looks like. So this is the basic unit. Can people actually see the code? No. Let's crank the font up. Sorry. Let's see. Options. Where's my options? Tools. Options. Sorry. Let's see. Text editors. Up. Oh, there it is. Of course, when I'm up here, it's very hard to find all the stuff. Sorry about the font. Let's see. Let's see if 16 is big enough. Let's make it 18. How about that? Can people see that? Much better. Okay, good. Thank you. Thanks for your help. First thing is, notice all these data contract attributes on top of an Inster item, or this particular data contract attribute on top of this class, the Inster item class. Now, I have data member decorating a whole bunch of properties on here. Now, it turns out that the data contract and data member attributes don't actually pay attention to whether or not this thing is a field or a property. They don't pay attention to the CLR protection modifiers on that particular field or property, whether it's private, protected, or public. If you annotate something with a data member, that thing is going to go on the wire. If you don't, it's not. It's as simple as that. So we basically, again, pried apart the details of the local contract system and the wire contract system. So that's what that guy looks like. Now, Inster peer looks very similar. I have a data contract, data member, and then when I have an interface, like for example an iInster peer, I can just send these guys out as parameters. And here I see what we call the parameter idiom for sending messages around. Now it turns out, I can actually show you, let me show you what comes out of the Amazon proxy for a slightly different manifestation of how this stuff can come out. So our metadata import system goes off and spits out proxies for things that it imports. And if I go search for message contract, I can actually see this is actually the long form for how to specify one of these things. It's just code spit, but I can just use message contract here, right? And then I can start annotating things with message body attributes. And this is, for example, the help request message. So if I look at help request message, that will be a single parameter that the help method will take, and it will likewise return a help response message that's also decorated with a message contract. The final thing I want to show actually is the contract for, let's see, Inster client service. By the way, all this code is going to be available on my blog sometime later on today, so you can play with it. This particular one takes an Inster item, which is a data contract, and returns a stream. It's important to remember that WCF actually does something special with messages and streams. It will actually go return you a stream reader to the content that it has, instead of trying to go deserialize some of the message. So you need a special kind of binding to support returning streams. And I'll talk about that a little bit more when I get to bindings. So that's what some of the message and data contract types all look like in a real program. Now let's talk about describing message exchanges. We have also some contract attributes there, a service contract and an operation contract. The service contract roughly corresponds to a WSDL port type, and the operation contract actually very closely ties to the WSDL operation. Now, in my operation contract, I can actually go specify what SOAP action that operation corresponds to, and what reply action I'm expecting for a synchronous call, right? So operation contract ties together a message contract, a type message, and an action. And that's exactly how WCF dispatches, right? It looks at a message that comes off the wire, looks at the SOAP headers, it sees the SOAP action header, it goes, okay, that's a URN, do it again. It goes and looks at all the metadata for its endpoints and all the operations inside of an endpoint, and it goes, this is where I need to dispatch to. So that's the key construct that ties together these two separate contract types, the message exchange contracts and the messaging, the data contracts. Message exchanges can be of various flavors. The most prevalent pattern that we have today is the request-reply pattern that HTTP gives us. Thank you, HTTP. And therefore, it's actually the simplest to go write code for in the WCF. You just use the operation contract attribute on a method that takes parameters and returns parameters, or takes a message and returns a message. A one-way message is merely adding an is one-way equals true modifier to that operation contract attribute, and a one-way operation returns a void naturally. Duplex contracts are basically taking two different one-way contracts and correlating them together in a single contract. The way I get that done is I have a modifier on that service contract attribute called callback contract, and I just give it a type of what the callback contract is going to be. And this is one of those very neat things, because over a transport that supports full duplex communication, such as TCP, I can actually go initiate from a TCP client a full duplex communication pattern. Now, of course, if I was addressable both ways, I could just create two one-way contracts and do the same thing. The nice thing about duplex contracts is that if the other side, if I'm the initiator and I'm not addressable, I can create a duplex contract, initiate communication with a service, and then that service can talk back to me over the backside of that communication, of that TCP channel, right? Now, it turns out that, like I mentioned, actions control dispatch, and I can go customize, if I want ultimate control, if I want the universal dispatcher, the one that gets basically all the actions, and just dispatches to a single method that will do all the demuxing, all the demultiplexing itself, this is actually my signature. I say operation contract, action equals star, take a message. That is the base communication pattern in WCF. Everything else is built on top of that. A couple of final notes about contracts. There's a distinction between request-reply contracts and asynchronous invocation, right? If I want a asynchronous, one-way contract, I can model that using a is one way equals true attribute, like I mentioned before. If I want a correlated request-reply, I can just omit that is one way equals true. Now, if I want the server side to go implement that contract using the CLR async pattern, for example, if I don't want to block the server on that call, I can actually go use the async pattern equals true modifier on that operation contract attribute and implement that CLR, that CLR pattern, which is begin and end, returning an async result and taking an async result respectively. Now, it's really important to note, this has nothing to do with the client side. The service side can do whatever it wants. It can go handle the communication synchronously, or it can handle it in an async manner. The client side can go call that particular method, chat, in a synchronous way, even if the service side is using the async pattern and vice versa. The client side can always call the begin and end pattern for that method, and the server side, and it doesn't really know or care about how the service implements it. So let's go back and look very quickly at the operation contracts, service contracts in this particular project. So, while we're waiting for Visual Studio to come back. Oh, here we are. I was just being impatient. Okay, so let's look first at this iDownload interface. It's kind of an interesting interface. It has a service contract, and it has an operation contract, just like the ones that we've seen before. It also has a fault contract. Now, this is how I designate that an operation can not only return a standard result, but also can return a SOAP fault. I decorate that particular method with a fault contract, and I say which type this particular fault is going to return. And here I just have a very simple string that I get back. Now, when I look at the code that utilizes this, let's take a look really quickly. It's actually in Insta Client Service. This is the get item code. I go do some stuff. Here it is. I try to... Oh, this is actually, sorry, this is the service code. Let me look at the client code real quick. It's in the form, view code. Here it is. So this is the yes, iDownload channel proxy equals cf.create channel. Right? So this is how I get my client-side channel for talking to this particular service. Now I basically get a stream back. I just call this get item, which was on my contract. That's the thing that returns me a stream. Actually, let's ignore this. I wrap this in a try-catch block. And then, if I actually get some exceptional condition on the service, for example, file not found, I catch it as a fault exception of type string. Then I actually have a message box.show here. It's not available. Right? Now, on the service side, I still have to catch that file not found exception, and throw a new fault exception, but that's how I return faults back to a caller. Now, let's finally look at the more interesting contract here, which is the peer contract, I-inster peer. This guy is a duplex contract, right? It's a service contract that has a callback contract of type I-inster peer. So this is kind of a symmetric duplex contract. The same methods that I call on that contract going out are going to be the methods that I get called on coming in. So all I have to do is pass the same type that I use, I-inster peer, to reflect that symmetric contract. Now, of course, I can make that contract, the duplex contract, asymmetric as well. Now, naturally, all of the operations on a duplex contract use is one way equals true. So here I have a few methods. For example, when I join, I go call the join method on my proxy, my peer channel proxy, and so I can go broadcast the join message to everybody else. Likewise, I do the same thing right before I terminate. I call leave. That chat button corresponds to that chat right here. This is when I broadcast my item list the first time I come up. And when I added that item that propagated out to all of the other peers, that's an added item and removed item methods here. And all of them are one-way operations. Let's see, I think I covered all the contract types. Good. So just to summarize contracts, we have a whole bunch of features here, but the ones I didn't quite get to in the demo are what we call session-full message exchange patterns as far as service and operation contracts. These are basically when I have a stateful session with a service, and I call first one operation, and I know that's the beginning operation, and I have an end operation that I know terminates the session. That's really useful metadata for the WCF, because on the service side, the WCF knows how to manage some of those sessions, some of the lifetime of the sessions, and so if I decorate with first method and last method, that tells my system, for example, that if I call something in the middle, it'll actually go throw a fault if I haven't called the first operation yet. And likewise, when I do call the first operation, it'll go cons up a new service instance. And when I call an operation that is designated as the last operation, likewise, it will tear down that particular service instance. And finally, if I want ultimate fine-grained control, of course, all of the communication details are available to me under the covers. If I want RPC literal, RPC encoded or document literal combinations, as specified by WSDL. If I have some old services that I'm talking to that are RPC encoded, I can use all that as well. Next up is bindings. Let's delve into bindings a little bit. So bindings are actually another interesting place where we've put in a lot of intellectual thought. We've for a long time wanted to separate the mechanism of communication from the actual stuff that happens on top. And so separating contracts and bindings is very important for us. There's a whole bunch of systems, a whole bunch of APIs that we've put out there as well today that tie a lot of the characteristics of my distributed systems API with a particular transport. For example, hosting in IS, you can only use HTTP as a transport for that. For example, if I have a messaging system, message-oriented middleware system, I really have to go use that MSMQ protocol or that MQ series protocol underneath the covers, even if I want that idiom of message passing. And that is appropriate for my application. Of course, all these things can tunnel over HTTP as well. But the key thing was separating the mechanism of communication from what I actually want to go do. And bindings basically are assembled of what we call channels. It's a channel stack. There are transport kinds of channels. There's encoders, and there's protocol channels. The transports are basically just the underlying transport that I use. We have support for TCP and HTTP, the peer, MSMQ, all those things. Right? We even have a named pipes one in the box that ships. I can create one of these guys as well, and it's not all that hard. We actually have a session that I'm going to forward reference a little later in the presentation on how to build your own transport channel. There's also encoders. We have a text encoder, which is the standard interop encoder, and a binary encoder that's appropriate for more optimized scenarios. And again, you can write your own custom encoder. And Doug Purdy, in his talk on WCF for XML developers, is going to show you how to go write one of these custom encoders for POX. Steve Main, who you saw at the keynote, Jim's keynote, wrote a JSON, JavaScript object notation encoder that knows how to send JSON instead of XML on the wire. So again, these things are very customizable. And finally, there are protocol channels. And these things are the things that know how to go put all the protocol goo inside the message. So for example, these things know how to go format the W security headers and the WS reliable messaging headers and the transaction headers and so on and so forth. All these things basically stack together in a channel stack. That's what, and bindings are basically a way to give a name to that particular channel stack. Now we have standard bindings, and these are the things that we think people are going to do over and over again. Right? You can create your own binding very easily by mixing and matching all of these standard components, but we also have standard monikers that we've created. One called basic HTTP binding corresponds to the BP11 binding. And so, for example, I can go talk to Amazon out of the box with that basic HTTP binding, because all it does is SOAP 11 and XML on the wire. That's all it needs. That one does transport-based security. It doesn't do WS security because it's just the BP11 binding. But if you want to do more interesting scenarios, more enterprise-oriented scenarios, for example, end-to-end message-based security or reliable messaging or transactions, you have the WS-HTTP binding, which is kind of the WS star binding, if you will. And we're spending a lot of time working out all the interop details of that binding with other software stacks, like the ones that are built for the Java platforms and some of the ones that are available out there, like, for example, the Access one. Now, in order to do duplex, we have a special HTTP binding called the dual binding that basically associates an outgoing and an incoming HTTP channel into a single duplex channel. And of course, this is useful only if both sides are accessible, both sides are reachable over HTTP. But this basically lets me simulate a duplex contract, or not even simulate, implement a duplex contract over HTTP as the communication mechanism. We have a net TCP binding. Net stands for .net. That is just basically sitting on top of raw TCP. It gives you everything. It gives you security, both transport and message-based security, sessions, transactions, duplex, etc. And it supports streaming. We have a named pipes one that's just a little faster, optimized for on-machine scenarios. We have one for MSMQ. That actually goes off and talks the MSMQ protocol as opposed to any W star stuff or any SOAP stuff. But it likewise supports a lot of these attributes. And finally, there's a peer channel binding called net TCP binding. This is how we integrate using bindings. Indigo, WCF can talk to a WCF client can talk to any WCF service using any of the bindings, obviously, right? But the way we integrate with our own software stacks is using that same mechanism. So we use HTTP and the WS bindings in order to talk from an ASMX or a WYSI3 client to a WCF service, or vice versa. Even more prevalently, if I have an ASMX service or a WYSI3 service deployed, I can go talk to those things using the HTTP and the WS binding. That's incidentally how we go integrate with other platforms as well. And the HTTP and the WS bindings are the ones that people are going to use in order to integrate with the Java platforms and so on and so forth. Now, Kirill Gavrilyuk and Simon Guest have an excellent interop talk later on this week. I will forward reference that as well. I'll give you some of the information on that. But they'll basically show you how all this interop works. And Mark Fussell has a session on how to integrate ASMX and WYSI3 services with new WCF clients. Finally, this is, again, you get the picture. This is how MSMQ works as well. Now, it turns out that bindings do have semantics. As you see, it's not a complete mix and match picture out there. And I'm reminded of a story when we released Com Plus some time ago. We used to have this capability where you could go, where the administrator could go change the transaction options, like transaction required and things like that, auto enlist, autocomplete, from the Com Explorer. And we got lots of support calls where folks would call in and say, hey, my database got corrupted. And we go, okay, what's going on? And they say, I don't know. What'd you change? Okay, well, I went into Com Explorer and I took that transaction required attribute off. Hey, it made my program run 10 times faster. Those silly developers, and they put all those things that make it all slow. So we go, okay, we know what that is. Well, one of the key things that we wanted to do is to make sure that we didn't kind of fall down that trap again. And so developers can actually assert the semantics that they require in their code. Now, service contract is one of those assertions. It, for example, asserts that it needs a duplex contract. So a binding that doesn't support a duplex contract, if you're not using the HTTP dual binding or you're not using the TCP binding, we're going to get a runtime exception. Likewise, streaming requires a particular binding type, and we can automatically figure that out. For things that we can't really figure out, you can actually go put those imperatively or declaratively, shall I say, in the code using the binding requirements attribute. So for example, if I require transactions, I can actually go put that in as a binding requirement, and then my binding and the underlying transport stack, or channel stack rather, has to support all that. So so the developer can ensure that nothing bad happens. So let's look very quickly at some bindings. We have a few different kinds of bindings. We have WS bindings, peer channel bindings, TCP bindings, basic HTTP bindings, all in this particular demo. Here, let's actually close these guys down. Let's close Omri down. And let's actually look at what some of these guys look like. Now, bindings are actually very boring to look at. All they are is just chunks of config. So I have a net TCP binding here. I have a net peer TCP binding for the peer channel, and I can go look at some of these attributes here. So for example, this you probably can't see, unfortunately. I can parameterize these in all sorts of ways. I have the listener IP address, the max buffer pool size, max message size, and the port. This is actually going to determine which port the peer channel is going to go listen to. Actually, let me undo all this. Now, the more interesting binding to look at is this custom binding. This is actually how I created the stream binding. If we look back up here, and I look at the client endpoints, let's see where it is. I'm sorry. The service endpoints. This particular endpoint with address download that corresponds to that client service, the one that takes a file name and returns you back a stream, has this custom binding, and the binding configuration is stream binding. So we can take a look at that real quick and see that all we have to do is assert that this is a composite duplex. That is, we want two-way communication here. And I go create a TCP transport with a max message size of 64 megabytes and a transfer mode of streams. Now I can go create a whole bunch of different I can go create a custom binding with all of these, kind of pre-canned components. For example, if I want the binary message encoding, I can use that instead of the text message encoding. If I want to use the HTTP transport instead of the TCP transport, I can go use that. If I want the MTOM message encoding, I want reliable sessions. If I want to go turn on WSRM, that's how I do it here, right? So using IntelliSense technology, we can go discover a lot about WCF. And in fact, that's how a lot of people who approach WCF for the first time kind of end up finding all this stuff around. For example, I can assert that I want ordered communication. Ordered equals true, if I can type. And I can also set all sorts of parameters here on acknowledgement interval and things like that. What else do I have here? I also have security. Security is a fun one. It has things like authentication mode. So I can, for example, authenticate over Kerberos. I can authenticate over a secure conversation, over username, password, over info cards. That's how I control all that stuff. Right? So all of these are basically things that I can do to create a custom binding that will create a new channel stack that gets automatically assembled by Indigo at runtime. So let me undo all these to make sure my code still compiles. Now, last but not least, I wanted to show you what the generated binding looked like coming out of the Amazon proxy. And that has a transaction flow equals OLATX, text message encoding, HTTP transport. It turns out WCF doesn't know how to go recognize that this is just a basic HTTP binding yet. And so it goes off and generates all this goo. It turns out that I don't need any of this goo to go talk to Amazon. All I need, so this is an endpoint that used that goo that I commented out, all I need is the basic HTTP binding and it all works fine. So that is bindings. Now, the peer channel folks have an excellent session on how to use the peer channel in kind of in more detail. That session is given by Sandeep, Com 311 on Tuesday. We have Doug Purdy's session that I already alluded to. He's going to show you how to use REST and POX from within WCF. He's going to show you also how to integrate with Xlink. There's an under the hood session by Steve Schwartz that's going to delve a little bit into the ins and outs of channels and bindings. And finally, there's a great talk by Yasser and Kenny, who are on the channels team for how to write your own channel. And they demonstrate through the UDP channel what it is you need to do in order to write your own. In the interest of time, moving a little quickly, metadata. So, like I mentioned, each service host, when it runs, it goes off and looks at all of the metadata that I've annotated an endpoint with, both ones that come from code, come from attributes, come from config. It goes off and it creates a metadata description for that particular endpoint. Now, what if I actually want to kind of short-circuit the development process, so to speak? I want to actually go grab that metadata and generate some stuff on my own. You can actually go extrude a WSDL contract out of any running service using, by default in the WCF. There's a particular attribute that controls that, and by default it's on. Once I have that WSDL, I can just go run it through a proxy generator to go create a proxy file, like I showed you with the Amazon proxy, and an app or web.config file. So let me show you really quickly what came out of, oops, what came out of the other side of that proxy generation. So let me actually, since I've already shown you the proxy, let me show you the code. So here I'm actually, this is a method. Actually, let's look at this one, get Amazon items. I pass an artist and a type. This is back at the very beginning of the demo when I showed you how I take an artist and I go return all of the albums associated with that artist and all the track information. I get my Amazon key, then I create an Amazon e-commerce service port type proxy. This is, again, a generated name, not something that I invented. But all I have to do is create one of these guys, right? And let me actually run this. This may be a simpler way of looking at it. So F5. Oh, great. Oh, okay, it's somehow I changed the server here. Let's see if I can just run F5 and use the last successful build. So it's going to go look into stuff. Oh, yeah. It's running. There it is. Are we at the breakpoint yet? I don't think we are. No, it's still up there. Yeah, unfortunately, this is going off, talking to the server, getting some stuff, booting up. We're going to give it 5, 4, 3, 2, 1. Okay, all right. Let's just look at what this is. Let me go to definition. This is what this guy is. This gets auto-generated as implementing what's called a client base, and also this particular port type, which is just the service contract. Let's actually go look at that really quickly. So here's the e-commerce service port type. It has a service contract attribute, right, just like you'd expect, and a whole bunch of operations. Let's go back really quickly to, oops, the, where are we? Amazon helper. It's still not up for some reason. I don't know why. Let's look at that guy again. So all the proxy is just a wrapper for some generated things. I basically have a message here. Let's look at actually the one that I am calling, which is, let's make sure I know what it is. Oops. Back to the helper. I'm calling something called item search. So the item search method right here, all it does is take an item search, which is, and then creates one of these message contract things, item search request message, which was decorated with the message contract attribute, gives it the value that I pass in, calls this particular method on a typed channel, right, and returns you back stuff. So again, now the proxy system, the code-generated proxy system on top of WCF is actually a very simple thing. There's not a whole lot of magic left in there. It is actually running. I don't know why it never hit the breakpoint, but oh well. All right. Interop, great session by Kirill and Simon on Thursday to give you more details about interop. It's built as a Java interoperability session, but it has a whole bunch of brand new demos, and they show you interoperating with not just Java platforms. The final thing I want to talk about is behaviors. Behaviors is a concept I haven't introduced yet because it's not really part of the contract, not part of the endpoint. These are localized behaviors that control the execution of the service and the client. So I can go enhance my service with some behavior definitions and my client with some behavior definitions. These are some of the things that we implement with behaviors. With security, for example, a lot of the security details are in the binding. For example, what authentication scheme I'm using, whether I'm doing transport or message-based security, all the things that control what's on the wire are in the bindings layer. But the things that actually control behavior are in the behavior layer. And the way I implement one of those things is either in config or in my code as a behavior attribute. So for example, the way that I do authorization on a method in WCF is I just use one of those behaviors, an authorization behavior, on my client-side code, or I'm sorry, on my server-side code. Likewise, behaviors let me control all sorts of things, like just-in-time activation, like instancing, like thread binding, like concurrency, all sorts of things, transactions. All these things are controlled using behaviors. Before I get off the security slide really quickly, we've not even managed to scratch the surface of security here. We just basically kind of poked around in bindings. Martin Gudgeon tomorrow has a great session on everything that has to do with security with WCF. There's an info card session that delves into that particular security system or credential system with Indigo, given by Andy on Thursday. And finally, there's a session on an in-depth session on extending the security system, for example, how to go write your own authorization models and things like that, given by Doug on Friday. Reliable messaging is another example here. Now, it turns out that RM doesn't need any behaviors. If you want to know more about RM, queuing, transactions, go to Shai's talk. It's right after Gudge's talk, right after Martin Gudgeon's talk. It's kind of the sister talk to the security talk, and that's tomorrow at 3:15. And Shai is known for doing snazzy demos. He actually has a great demo this time around too. It's probably going to be one of the best out of the breakout sessions, so I highly recommend going to that. And finally, transactions. The bindings obviously have to flow the transaction headers, because at the end of the day, a lot of the transaction propagation in WCF and in W star is done via these transaction headers, right? But the behaviors are what control things like auto-enlisting, auto-completing, and things like that. And again, Shai is covering that in a lot more detail tomorrow. Using behaviors, let me actually just go poke around behaviors just a little bit, just to show you what you can possibly do with behaviors. Let's stop this guy. So let's look at some of the behaviors that we have in this particular system. So for example, I think yes. So this particular service, the Insta client service, has a service behavior attribute. It basically says, set my instance context mode. That is, when I wake up, just create a single service instance and route all of the messages to that, as opposed to doing something different. For example, per call, create a new service instance per call, or some of the other options on here. Right? Let's look at more dot technology here. Run on UI thread means, hey, if this particular service was started on the UI thread, I want to make sure that you start a new thread for it so that I don't get deadlocks. Like, for example, I'm calling out on the UI thread on a blocking call to that same service, and that service tries to dispatch on that same thread that my UI is blocked on. This actually goes off and helps those kinds of problems. And if we look at more attributes, there's all sorts of stuff here. Let's see. There is transaction isolation level. Transaction isolation level equals transaction isolation. Oops. Yep, so I can actually go control what the transaction isolation level looks like as well. So this is what behaviors give you. Now, again, back. The Steve Schwartz companion sessions, the second Under the Hood session, Thursday at 10, actually delves deeply into the service model layer and explains all about behaviors. And Mike Vernal is giving a great talk on how to extend the service model by creating your own behaviors. Those are the two real important extensibility points in the WCF. One is the behavior system that enables you to go create new behaviors for the system, and the other one is the channel system. So all those things that I talked about, for example, metadata customization by default, I have a metadata behavior that by default will expose this endpoint to return metadata when I send it a particular string, like a WS metadata exchange request, or just put !WSDL on the URL. Things like just-in-time activation, all the security system, all the security gates that we have, impersonation, authorization, all of those are controlled with behaviors. So this is basically the final content slide. This is a graphical depiction of really a whole bunch of Indigo. The majority of the Indigo feature set really lives on this slide. And this is really what the Indigo runtime system uses in order to go construct all the runtime artifacts to go make communication happen. You have addresses that we talked about. You have bindings, all sorts of bindings. You have different protocols. You can stack more than one protocol, so you can stack the security protocol with the RM protocol, with a coordination protocol, etc. Contract type, and all the kinds of behaviors all composed together to form the runtime system. So we have a whole bunch more resources for you. This is just basically grazing the surface of the WCF. We have about 20 WCF or WCF-related sessions. I have a whole bunch of these that I alluded to. I think these slides are going to go on the ComNet really soon. And so you'll be able to go take a look at some of those pointers in there. But some of the ones that I haven't mentioned are John Shuchuk, excellent speaker, is going to give an identity and access talk and talk about info cards and how that fits in the identity meta system. How to integrate COM+ and MSMQ applications. We have a whole session on that tomorrow at 11. Managing services, the whole manageability topic is going to be explored by Alex tomorrow. Hosting services, Steve Main, the same guy who did the JSON stuff up on during Jim's keynote, is going to give a session on hosting services, mostly focused on WAS, the Windows Activation Service. The tips and trick session is obviously always popular. John Justice is going to do a good job here too. And finally, ASMX and WYSI integration is going to be covered by Mark on Friday. All these sessions are good sessions. I encourage you to go to them. You've now gotten all of the details, all the basics that you need to know in order to go to the hands-on labs. And we have 11 really well-crafted hands-on labs that will take you through all the details, from the basic services all the way through security, reliable messaging, queuing, integration with COM, both ways. Actually, for example, taking from VBA, being able to call an Indigo service, things like that. And all sorts of other labs. We have one on Peer Channel, one on InfoCard. It's all good. Finally, this is my email address, omrig@microsoft.com. Feel free to send me any questions. I'll try to get to email sometime later on today. And I will post this code later on today after I've been able to kind of fully connect back to the office, so to speak, on my blog, which is gazitt.com/blog. So thank you very much. Please fill out an eval. Thanks a lot. This really does help us, kind of tweak our sessions for the future. So I really encourage you to fill one out. Thank you.